Hello, everyone. With a great vision of India's future, Dr. Vikram Sarabhai put forward the proposal of promoting space in India. India's space program has become one of the world's topmost space sector by a low budget first attempt success missions. In this video, we will take a journey from origin to expansion of ISRO by learning about space in India. Before we dive deep into the topic, let me ask you a few questions. Which year was ISRO established? What was ISRO named as before? Where did first launch happen? In the course of this video, we will be discussing about all this. Dr. Vikram Sarabhai, considered as the father of Indian Space Agency, while doing his masters in physics in England, came back to India due to World War. He undertook research in cosmic rays under Sri C.V. Raman at Indian Institute of Science, Bengaluru. He returned to Cambridge to pursue a doctorate and wrote a thesis on cosmic ray investigations in tropical latitudes in the year 1947. At the age of 28, he founded the Physical Research Laboratory on November 11, 1947, in Ahmedabad, and it helped to develop the nuclear power. He was a great institution builder, and he has established or allowed to establish a large number of institutions in the diverse fields. Dr. Sarabhai was closely associated with Homi Jahangir Bhabha, S.S. Bhatnagar, and Sri C.V. Raman. Dr. Bhabha has proposed space research as a part of Department of Atomic Energy. In the year 1962, with the support of India's first Prime Minister, Sri Jawaharlal Nehru, Indian National Committee for Space Research, INCOSPAR, was set up, and Dr. Sarabhai was recommended to chair the committee. INCOSPAR was later changed into Indian Space Research Organization, ISRO, in 1969. Subsequently, the Government of India constituted the Space Commission and established the Department of Space in June 1972 and brought ISRO under Department of Space in September 1970. Does anyone know why Thumba was chosen for um, as the place to set up, and why have they chosen the Thumba, and where this Thumba is? The architect of Indian Atomic Energy Program, Dr. Homi J. Bhabha, together with Dr. Sarabhai, were scouting for a suitable location to establish India's first rocket launching station. Such a site should be isolated, near to the sea, and close to magnetic equator. In 1962, during their pursuit along the southern coast of India, they came across a quiet fishing hamlet and also a red sandstone church dedicated to Saint Mary Magdalene at Thumba. Thumba was on the outskirts of Thiruvananthapuram, Kerala, on the deep coast of Arabian Sea, and it was also close to the magnetic equator. The church was surrounded by a vast 600 odd acre land and lay between the coast and the railway line. The location aligned with the Earth's magnetic equator. क्या हो गया? अच्छा, कहाँ कहाँ से करना है? थुम्बा से करते हैं फिर ये इससे थोड़ा ऊपर ले चलिए, थुम्बा वाले से। वाई वॉज इसरो स्टार्टेड इन थुम्बा, उसमें थोड़ा सा गड़बड़ हो गया, इससे थोड़ा सा ऊपर लीजिए। हाँ, बस यहाँ से. Does anyone know why they chose Thumba? And where is Thumba? The architect of Indian Atomic Energy Program, Dr. Homi J. Bhabha, together with Dr. Sarabhai, were scouting for a suitable location to establish India's first rocket launching station. Such a site should be isolated, near to the sea, and close to the magnetic equator. In 1962, during their pursuit along the southern coast of India, they came across a quiet fishing hamlet and also a red sandstone church which was dedicated to Saint Mary Magdalene at Thumba. Thumba was on the outskirts of Thiruvananthapuram, Kerala, on the deep coast of Arabian Sea, and it was also close to the magnetic equator. The church was surrounded by a vast 600 odd acre land and lay between the coast and the railway. The location aligned with the Earth's magnetic equator, and it became the ideal spot to start India's space program. With the establishment of a rocket launching site and a research development center. Do you know what is a magnetic equator? Magnetic equator is an imaginary line roughly parallel to the geographical equator and passing through those points where a magnetic needle is horizontal when freely suspended in the air. And why is this magnetic equator so important? The magnetic equator is important because the sky right above the magnetic equator has a stream of electrons that produce the electrojet, and it is very useful for scientists to know about the meteorology, aeronomy, etc. Dr. Sarabhai requested the bishop, Reverend Father Peter Bernard Perseria, to transfer the property for this nation building program. Later, at a congregation, the bishop announced, "This scientist needs our church and the place where I live for the space research program for the country. Can we give this to the scientific mission, because both science and spirituality seek the Almighty's blessings for human prosperity in mind and body." Everyone agreed to it, and nearly 90 acres of the church land, including a primary school, was given for the program. Over 183 families were shifted, and the church and the school were built in another place. While establishing the facility at Thumba, care was taken to ensure proper rehabilitation of the displaced persons, and the coastal environment was protected and nurtured. The church's prayer room was the scientist's laboratory, and the bishop's quarters became the design and drawing office. Thus, the Thumba Equatorial Rocket Launching Station, TERLS, was established in Thiruvananthapuram, now widely known as Vikram Sarabhai Space Center, VSSC. Image on the slide shows engineer building rockets in the church and Nike Apache for the launch. Today, the church is turned into VSSC Space Museum in Thiruvananthapuram. Every organization has a mission and a vision, which will drive the team to achieve the goals set by its founders. Unlike other space agencies, ISRO's pioneers dreamt for making lives better through space, and the vision was to harness space technology for national development while pursuing space science research and planetary exploration. ISRO's mission broadly aims to design and develop launch vehicles, satellites, and related technologies for providing navigation, meteorology, space science, planetary exploration, and space based applications for societal development. It clearly says that the space technology must be for nation building and to explore the planetary science. Every great thing starts from small steps, and so did the Indian space program. From carrying a payload on the bicycle to making a successful launch to Mars orbit, ISRO has taken a giant journey so far. As you can see on the slide, Indian space program has three distinct elements, namely space infrastructure, space transportation system, and space application. Space infrastructure is about designing and building satellites and maintaining outer space activities. Space transportation system refers to building and launching of launch vehicles. Space application is to make use of data provided by satellites and other ground stations to help people working in every possible step. The sounding rocket called Nike Apache was India's first rocket launched from Turles on November 21st, 1963. The rocket system was loaned by NASA and the sodium vapor payload was provided by French National Space Agency. The launch was a success and helped provide the data for wind systems above 80 km of the Earth's atmosphere. Later, ISRO developed its own series of indigenous sounding rockets called Rohini, and the maiden flight of Rohini 75 was carried out on November 20th, 1967. The Space Science and Technology Center, SSTC, on Valley Hills near Thumba was established in 1965 to initiate the research on developing components and systems for launch vehicles and rockets. In 1967, the experimental satellite communication Earth station was operationalized in Ahmedabad. It was instrumental in training Indian and international scientists and engineers. Rocket Propellant Plant RPP was developed by the Chemical Engineering Division of Bhabha Atomic Research Center to produce solid propellants in 1969. With the increase in number of rockets fabricated, another facility called Rocket Fabrication Facility RFF was commissioned in 1971 to produce rockets from hardware developed in SSTC. Later, in July 1972, TERL's SSTC RPP RFF Propellant Fuel Complex and the Indian Scientific Satellite Project Bengaluru came under the umbrella of Vikram Sarabhai Space Center VSSC. The ISSP at Bengaluru was reconstituted as ISRO Satellite Center ISAC in November 1976, which was renamed after its founder, Professor U.R. Rao, who is known as the father of Indian satellite program. ISRO went on to take small experimental projects to estimate the usage of space applications in India, starting from rural regions with an educational television program. Satellite Instructional Television Experiment SITE was a successful experimental satellite communications project launched in India in 1975, designed jointly by NASA and ISRO. The main objectives of the experiment were to educate the financially backward and academically illiterate people of India on various issues via satellite broadcasting and help India gain technical experience in satellite communications. There are many veterans in the space science, technology, and applications who guided and provided leadership in various scientific and technological development areas. Later, ISRO indigenously built the first Indian satellite Aryabhat and was successfully launched on a Soviet rocket on April 19, 1975. The satellite was 360 kg in weight with a mission life of 6 months, but it was operational for 13 years. Satish Dhawan Space Center, Shar, the spaceport of India, is located in Sriharikota, the spindle shaped island of SPSR, Nellore district of Andhra Pradesh, about 80 kilometers north of Chennai. The space center, which was popularly known as Sriharikota High Altitude Range, SHAR, was renamed as Satish Dhawan Space Center SHAR on September 5th, 2002, in fond memory of Professor Satish Dhawan, former chairman of ISRO. The site was chosen in 1970 to set up satellite launch station. Features like good launch azimuth corridor for various missions, nearness to the equator, and a largely uninhabited area for a safety zone have made Sriharikota the ideal location for the spaceport. SDSC Shar became operational on October 9, 1971 with the flight of Rohini 125. The development of sounding rocket provided good technical experience, leading to development of India's first satellite launch vehicle, SLV-3, capable of placing a 40 kg payload in low Earth orbit. The first mission was completed on July 18, 1980 from Sriharikota range. The project director of SLV-3 was Dr. APJ Abdul Kalam, who later rose to the highest position of President of India. Eminent leaders have led ISRO during the past 5 decades. Dr. Vikram Ambalal Sarabhai chaired ISRO from 1963 to 1971. Professor M.G.K. Menon from January to September 1972. Professor Satish Dhawan from 1972 to 1984. Professor Udupi Ramachandra Rao from 1984 to 1994. Dr. Krishna Swami Kasturi Rangan from 1994 to 2003. Sri G. Madhavan Nair from 2003 to 2009. Dr. R. Radhakrishnan from 2009 to 2014. Sri A.S. Kiran Kumar from 2015 to 2018. Dr. K. Sivan from 2018 to 2022. Currently, Sri S. Somnath is serving as the Chairman ISRO, Secretary Department of Space and Chairman Space Commission. ISRO has many centers spread across the country. Can you name any ISRO center? The Government of India constituted the Space Commission and established the Department of Space in June 1972 and brought ISRO under Department of Space in September 1972. As you are seeing in this image, ISRO has many centers spread across the country. We will go through all the major establishments of DOS ISRO centers and their area of activities. Vikram Sarabhai Space Center, VSSC, is the lead center for developing satellite launch vehicles and associated technologies. The major programs at VSSC include the development of Polar Satellite Launch Vehicle PSLV, Geosynchronous Satellite Launch Vehicle GSLV, Geosynchronous Satellite Launch Vehicle Mark III, sounding rockets, space capsule recovery experiment, reusable launch vehicles, and air breathing propulsion vehicles. VSSC has an ammonium percolate experimental plant at Aluva near Kochi. VSSC has extension centers at Valimala, Thiruvananthapuram, housing major facilities of mechanisms, vehicle integration and testing, and one at Vattiyur, Kavu, Thiruvananthapuram to develop composites. The Space Physics Laboratory at VSSC carries out research in atmospheric and related space sciences. The center pursues research and development in the fields of avionics, composites, computer and information, control, guidance and simulation, launch vehicle design, mechanical engineering, mechanisms, vehicle integration and testing, propellants, polymers, chemicals and materials, propulsions and systems reliability, program planning and evaluation, technology transfer, and industrial coordination and human resources development are also handled at VSSC. U.R. Rao Space Center, URSC, formerly known as ISRO Satellite Center, located in Bengaluru, is the premier center for research and development of satellite systems and technologies. URSC is carrying out conceptualization, design, fabrication, testing, and integration and in orbit commissioning of satellite systems through time bound projects. Space Astronomy Group has been involved in optical, X ray, and gamma ray astronomy research, emphasizing instrumentation. Cutting edge technologies meeting various mission requirements are developed in the center, making URSC forefront of the spacecraft technology frontiers. The program management offices coordinate the implementation of INSAT, IRS, and small satellites and satellite navigation programs. URSC has a unit called Laboratory for Electro-Optic System situated in Bengaluru and is mainly responsible for research, optical systems, development and product ionization of sensors for ISRO programs. URSC has 7 major areas: mechanical system area, mission development area, communication and power systems area, controls and digital area, integration and checkout area, systems production area, and reliability and quality control area. Satish Dhawan Space Center, SDSC, Shar at Sriharikota is the primary launch center of ISRO, carrying out launch operations with 2 launch pads for PSLV and for GSLV. By virtue of its location, it is known to be the second best launch center in the world. The launch complex contains integration facilities of different stages of launch vehicles, transportation facility, assembly building, tracking radar, telecommand systems, instrumentation, technical photography, safety, and security system. SDSC Shar has a separate launch pad for launching the sounding rockets. SDSC Shar houses 2 active launch pads, the first launch pad FLP and the second launch pad SLP. PSLV rocket is launched from FLP, whereas GSLV Mark II and GSLV Mark III rockets are launched from SLP, and they are not limited to PSLVs only. The first launch pad works on integrate transfer launch principle. That is, launch vehicle is integrated on the static launch pad and the portable vehicle assembly building is moved away from the launch pad after the assembly. The launch vehicle gets assembled inside the vehicle assembly building on the mobile launch pedestal for second launch vehicle. Later, the assembled launch vehicle along with MLP is moved to the launch pad on a track using a bogie. Cryopropellants are ground stored and pumped into the launch vehicles during the last phase of the mission. Final checks are made on the launch pad just before the rocket gets launched. The whole process of assembling the launch vehicles to launching takes 4 to 7 days, depending on the type of launch vehicle. Liquid Propulsion Systems Center LPSC is the center for designing, developing, and realizing liquid propulsion stages for ISRO's launch vehicles and satellites. Development of fluid control valves, transducers, propellant management devices for vacuum conditions, and other key components of liquid propulsion systems are also under the purview of this center. The center is also pursuing the development of a high thrust semi cryogenic engine for unified launch vehicle and reusable launch vehicle. LPSC activities and facilities are spread across two campuses, LPSC Valaimala, Tiruvananthapuram, and LPSC Bengaluru, Karnataka. LPSC Bengaluru is responsible for designing and realizing the propulsion systems for remote sensing and communication satellites and for other scientific missions. LPSC Valaimala is responsible for research and development, system design, engineering, and project management functions. ISRO Propulsion Complex IPRC Mahendragiri is equipped with the state of the art facilities necessary to realize the cutting edge propulsion technology products for the Indian space program. At IPRC Mahendragiri, activities include ground testing of Earth storable propellant stages, cryogenic stages for launch vehicles, high altitude testing of upper stage engines and spacecraft thrusters, testing subsystems, production, and supply of cryogenic propellants for the Indian cryogenic rocket program. A semi cryogenic cold flow test facility established at IPRC Mahendragiri works for the development, qualification, and acceptance testing of semi cryogenic engine subsystems. IPRC delivers liquid and cryo stages after integration to the launch pad for final testing and assembly. IPRC carries out research and development and technology development programs towards the continued improvement and advancements of its contribution to the Indian space program. Space Application Center SAC at Ahmedabad is spread across two campuses with multidisciplinary activities. The center's core competence lies in developing spaceborne and airborne instruments and payloads and their applications for national development and societal benefit. These applications are in diverse areas and primarily meet the country's communication, navigation, and remote sensing needs. Main engine and stage test facility at SAC designs and develops the optical and microwave sensors for the satellites, signal and image processing software, GIS software, and many applications for Earth observation programs of ISRO. These applications are in diverse area of geosciences, agriculture, oceanography. The facilities at SAC include highly sophisticated payload integration laboratories, electronic and mechanical fabrication facilities, environmental test facilities, system reliability assurance group, image test facility, image processing and analysis facilities, project management support group, and a well stocked library. SAC has active collaborations with industry, academia, national and international institutes for research and development. The center also conducts 9-month postgraduate diploma course for students from Asia Pacific region under the aegis of Center for Space Science and Technology Education in Satellite Meteorology and Communication in association with United Nations. Development and Educational Communication Unit, DECU, Ahmedabad, is an independent entity and has a definite role in meeting the goals of ISRO in promoting the usage of space technology for the benefit of ordinary people. DECU is involved in conceptualizing, defining, planning, implementation, and socio-economic evaluation of the space program applications. ISRO Telemetry Tracking and Command, ISTRAC, provides mission support to low Earth orbit satellites and launch vehicle missions. ISTRAC has its headquarters and a multi mission spacecraft control center in Bengaluru. It has a network of ground stations at Bengaluru, Lucknow, Sriharikota, Port Blair, and Thiruvananthapuram in India, besides stations at Mauritius, Tromsø, and Svalbard in Norway, and Troll, Antarctica, Brunei, and Biak in Indonesia. ISTRAC also operates the local user terminal mission control center under the International Program for Satellite Aided Search and Rescue. The Indian Deep Space Network IDSN consists of two large parabolic antennas with 18-meter diameter and 32-meter diameter at Bailalu village near Bengaluru, capable of supporting a mission to the moon and beyond. ISTRAC has also been mandated to provide space operation support for deep space missions of ISRO, undertake the development of radar systems for launch vehicle tracking, and for meteorological applications. The Master Control Facility at Hassan in Karnataka and Bhopal in Madhya Pradesh monitors and controls all the geostationary, geosynchronous satellites of ISRO, namely INSAT, GSAT, Kalpana, and IRNSS series of satellites. The Master Control Facility is responsible for orbit raising of satellites, in orbit payload testing, and on orbit operations all through the life of these satellites. MCF activities include round the clock tracking, telemetry and commanding operations, and special operations like eclipse management, station keeping maneuvers, and recovery actions in case of contingencies. ISRO Inertial Systems Unit IISU at Thiruvananthapuram conducts research and development in inertial sensors and systems and allied satellite elements. IISU is organized into research and development groups in launch vehicle inertial systems, spacecraft inertial systems, inertial systems production and reliability, and quality assurance. It has precision fabrication, assembly, clean room, and integration and testing facility. The unit has a total capability to design, develop, qualify, and deliver inertial systems for all programs of ISRO. Laboratory for Electro-Optic Systems, LEOS, is engaged in designing, developing, and producing electro-optic sensors and camera optics for satellites and launch vehicles. The sensors include star trackers, earth sensors, sun sensors, and processing electrons. The optic systems include both reflective and refractive optics for remote sensing and meteorological payloads. LEO's other optical elements for in house use include optics for star sensors, lunar laser ranging instrument LLRI, optical masks for sun sensor, optical filters, and encoders. LEOS is actively involved in developing new technologies for present and future satellite missions of ISRO. National Remote Sensing Center NRSC at Hyderabad is responsible for remote sensing data acquisition, processing, data dissemination, aerial remote sensing, and decision support for disaster management. NRSC has a data reception station at Shadnagar near Hyderabad to acquire data from Indian remote sensing satellites and others. The center is also engaged in executing remote sensing application projects, collaborating with the users. Regional Remote Sensing Centers RRSCs support various remote sensing tasks specific to their regions and at the national level. RRSCs are carrying out application projects encompassing all the fields of natural resources like agriculture and soils, water resource, forestry, oceanography, geology, environment, and urban planning. The Aerial Services and Digital Mapping ASDM area provides end to end aerial remote sensing services and value added solutions for various large scale applications like aerial photography and digital mapping, infrastructure planning, scanner surveys, aeromagnetic surveys, large scale base map, topographic and cadastral level mapping, etc. Indian Institute of Remote Sensing at Dehradun is a premier institute with the objective of capacity building in remote sensing and geoinformatics and their applications through education and training programs at postgraduate level. The institute also hosts and supports the Center for Space Science and Technology Education in Asia and Pacific CSSTEAP affiliated with the United Nations. The training and education programs conducted by the institute are broadly grouped into postgraduate diploma courses, certificate programs, and awareness programs. In addition, IIRS also conducts special programs for international and national participants on request from different organizations. Physical Research Laboratory PRL at Ahmedabad is an autonomous institution supported mainly by Department of Space. It is a premier institute engaged in basic research in astronomy and astrophysics, space and atmospheric sciences, geosciences, planetary sciences, and exploration and theoretical physics. The activities cover a broad spectrum of research in all these areas. PRL was the lead center for science planning of the Chandrayaan 1 mission that led to the path breaking discovery of the presence of water and hydroxyl molecules on the lunar surface. PRL is also involved in conducting extensive academic programs for doctoral and postdoctoral research and has an associateship program for university teachers. Studies of stellar and solar astronomy are conducted from the Infrared Observatory at Mount Abu and a lakeside solar observatory in Udaipur, respectively. Another campus at Thaltej, Ahmedabad hosts the Planetary Exploration Planex program. National Atmospheric Research Laboratory NARL at Gadanki near Tirupati is an autonomous society supported by Department of Space. It is a center for atmospheric research. NARL is involved in technology development, observations, data archival, dissemination, assimilation, and modeling. NARL carries out its research activities under seven major groups, namely Radar Applications and Development Group, Ionospheric and Space Research Group, Atmospheric Structure and Dynamics Group, Cloud and Convective Systems Group, Aerosols, Radiation and Trace Gases Group, Weather and Climate Research Group, and Computers and Data Management Group. Apart from these groups, there are also specific projects such as LIDAR project and Advanced Spaceborne Instrument Development Project. Indian Institute of Space Science and Technology IIST is Asia's first space university. It is a residential institution located at Valaimala, Thiruvananthapuram, and was established in 2007 to offer high quality education in space science and technology to meet the demands of Indian space program. IIST offers undergraduate, postgraduate, doctoral, and postdoctoral programs in broad areas of space science, technologies, and applications. IIST has a faculty strength of nearly 100 and spreads across seven departments, and about 500 students from various parts of the country are pursuing their undergraduate and master's course at IIST. Northeast Space Application Center, NESAC, located at Shillong, is a joint initiative of Department of Space and Northeastern Council to provide developmental support to Northeastern region using space science and technology. The center coordinates with state remote sensing application centers of Northeast region. It acts as a nodal center for implementing major national and regional programs on natural resources, management, infrastructure planning, healthcare, education, emergency communication, and early warning for disaster management support and atmospheric science research. The Antriksh Corporation Limited ACL Bengaluru is the marketing agency under Department of Space with access to resources of Department of Space as well as Indian space industries. ACL markets subsystems and components for satellites, undertake contracts for building satellites to user specifications, provides launch services, tracking facilities, and organizes workforce and software development training. New Space India Limited NSIL incorporated on 6 March 2019 under the Companies Act of 2013, is a company owned by Government of India under the administrative control of Department of Space. The major business areas of NSIL include production of polar satellite launch vehicle and small satellite launch vehicle through industry. Production and marketing of space based services, including launch services and space based application like transponder leasing, remote sensing, and mission support services. Building communication and Earth observation satellites as per the user requirement. Transfer of technology developed by ISRO centers and units and constituent institutions of Department of Space, and marketing spin-off technologies and product services emanating out of ISRO activities. Human Space Flight Center HSFC Bengaluru was inaugurated on January 30th, 2019 by Dr. K. Kasturi Rangan, former chairman ISRO, in the presence of Dr. K. Sivan, former secretary Department of Space and chairman ISRO. HSFC shall be responsible for implementing the Gaganyaan project, which involves end to end mission planning, development of engineering systems for crew survival in space, crew selection and training, and pursuing activities for sustained human spaceflight missions. Now we will be learning about few of the milestones in development in depth during the program. 16th February 1962, the establishment of INCOSPAR was carried out. On 21st November 1963, the first rocket Nike Apache was launched in India from the shores of Thumba, Trivandrum. In 1965, Space Science and Technology Center was established in Thumba. In 1967, Satellite Telecommunication Earth Station was set up at Ahmedabad. On 20th November 1967, India's first indigenous sounding rocket, Rohini 75, was launched. 2nd February 1968, TERLS was dedicated to United Nations. On 15th August 1969, Indian Space Research Organization ISRO was formed under the Department of Atomic Energy. On June 1st, 1972, Space Commission and Department of Space was set up and ISRO was brought under Department of Space. On 1st January 1975, Satellite Instructional Television Experiment site was conducted. On 19th April 1975, ISRO's first Indian satellite Aryabhatta was launched. On 18th July 1980, the first indigenous launch of SLV-3 was successfully placed this Rohini satellite in the orbit. On June 19, 1981, Apple, an experimental geostationary communication satellite, was successfully launched. On 3rd April 1984, Rakesh Sharma flew aboard the Soviet Suzuki T-11 rocket to the space station Salyut 7. On 17th March 1988, launch of first operational Indian remote sensing satellite IRS-1A was carried out. 5th May 1994, ASLV D4 was successfully launched. On 29th of September 1997, the first operational launch of PSLV with IRS-1D on board satellite was placed successfully in the orbit. On 26th of May 1999, IRS-P4 OceanSat, the first satellite primarily built for OceanSat application, was launched. On 18th April 2001, the first developmental launch of GSLV D1 with GSAT 1 on board was done from Sriharikota. On 5th May 2005, Cartosat 1 was launched by PSLV C6. Images from the satellites are available from GeoEye for worldwide distribution. On 10th January 2007, PSLV C7 was successfully launched the four satellites, namely Cartosat 2, Space Capsule Recovery Experiment Satellite, Indonesia's Lapan TubeSat, and Argentina's Punsat 1. On 22nd January 2007, successful recovery of SRE-1 after maneuvering it re- to re-enter the Earth's atmosphere and descend over the Bay of Bengal about 140 kilometers east of Sriharikota. On 22nd October 2008, PSLV C11 was successfully launches the Chandrayaan-1 from Sriharikota. 23rd September 2009, OceanSat-2, designed to provide service continuity for operational users of Ocean Color Monitor instrument on OceanSat-1 and enhancement of applications in other areas. On 20th April 2011, YouthSat, a joint Indo-Russian stellar and atmospheric satellite mission with the participation of students, was successfully carried out. On 26 July 2013, INSAT 3D, an advanced weather satellite of India configured with improved imaging system and atmospheric sounder, was launched. On 5th of November 2013, PSLV C25 successfully launches Mars Orbiter mission spacecraft from Sriharikota. On 18th December 2014, experimental suborbit flight was tested. The payload care module re-entered the atmosphere. On 8th July 2015, PSLV C30 launched AstroSat into the orbit. On 23rd May 2016, reusable launch vehicle technology demonstrator was launched. On 22nd June 2016, the Cartosat 2 series satellite, the primary satellite that was carried by PSLV C34, was launched. On 15th February 2017, ISRO created world record by launching 104 satellites on a single PSLV C37 rocket. Cartosat 2 series satellite was also launched. On 12th January 2018, PSLV C40 carries a microsatellite built by ISRO as a co-passenger payload. This is a technology demonstrator and forerunner for future satellites of the series. On 5th July 2018, the successful testing of launch abort system for the Gaganyaan mission was carried out. 22nd July 2019, successful launch of GSLV Mark III M1 carrying Chandrayaan-2 mission was successfully carried out. The mission failed to land on the surface of the moon. On 27th November 2019, Cartosat 3 satellite, the third generation agile advanced satellite having high resolution imaging capability, was launched. On 1st January 2020, ISRO shortlisted candidates from Indian Air Force for Gaganyaan mission. We thank you all for being a part of ISRO's journey throughout. Thank you.